Alright, 24, some of my favorite problems. Exponent problems. These always work out so cleanly. So the trick to these problems is always getting the bases to be the same. So they want to know for what real value of x is 2 to the x times 4 to the fifth divided by 2 to the third raised to the fifth equals 1/8. Alright, so what I want us to note is that for the most part our bases are 2, except for this one pesky base of 4. Well, if you think about the lower bases are 2. We want to convert that higher base to the lower base of 2. That's going to allow us to use the rules of exponents and therefore solve this problem. So let's go ahead and start our conversion process. We're just going to rewrite the numerator. That's 2 to the x. Well, we can represent base 4 using base 2. So we can basically say that 2 squared equals 4, right? So 2 squared equals 4. So if 2 squared equals 4, then we can rewrite 4 to the fifth as 2 squared raised to the fifth power. And let's do at least one step of simplification here. Power rule of exponents states that power to a power we multiply. That's going to be 2 to the 15th power. Alright. And this is all equal to 1/8, right? This is all equal to 1/8. I am going to save some space here and I will simplify and then I'll set it equal to 1/8 at the end here. So if we simplify our numerator one time, we'll leave 2 to the x to start. But again, power rule states that we multiply our exponents. So 2 to the x times 2 to the 10th divided by 2 to the 15th. And then our next step here, product rule. So since we're multiplying our exponents, we add them. So that is going to be equal to 2 to the x plus 10 divided by 2 to the 15th. And get this out of the way. Now we can use our quotient rule, which states that when we divide like bases, we can subtract the exponents. So that's going to tell us that 2 to the x plus 10 minus 15. And if we go ahead and simplify that one step further, that's going to be 2 to the x minus 5. Now finally what we can do is we can say that that is equal to 1/8. If you're doing this out algebraically like we are right now, then we can recognize that 1/8 is actually, or can be rewritten using base 2. Using negative exponents, 2 to the negative 3 is 1/2 to the third power, which is 1/8. So we could rewrite this whole statement here. We could rewrite that as 2 to the x minus 5 equals 2 to the negative 3. Make that 3 a little better. And now since our bases are the same, we can set our exponents equal. X minus 5 equals negative 3. If we add 5 to both sides, we will end up with x being equal to 2, which is our answer. Great. I would be remiss to state that just for standardized test purposes, a lot of exponent problems, since you do have a calculator on the ACT, these can be solved by plugging in your answer choices here. You could just sit through and effectively kind of test each of your answer choices. So what I'm saying is, like, if you wanted to check F, you could sit here and you could say to yourself, okay, well, what if I plugged in X as 1? Does this, if I evaluate everything in my calculator, does that equal 1/8? And if it does, then you've got your answer. 1 won't work out. So when you go and try 2, you're going to replace X with 2. You're going to evaluate that, and lo and behold, you're going to be equaling to 1/8. So that is completely and utterly valid.